Hello and welcome back to AP Human Geography. Today we want to talk about medical geography. We want to talk about global disease patterns and tracking disease. So when we talk about medical geography, we're specifically talking about the relationship between disease and the environment, right? And this is the same thing we've been talking about when we're talking about any kind of geography. But medical geography is going to apply human geography, right? So we can understand how those relationships influence human health, right? So questions like how do regional differences explain geographical variations in disease? So basically, why does this area get more of this particular illness than this area, right? How do changes in the physical environment affect rates of disease? Is it during monsoon time? Are you going to have more incident rate of disease, right, than you do during the dry season, okay? And then finally, and probably the most important part, is how can you use these patterns as a tool for disease prevention, okay? And these are just two maps that I wanted to show you, and these are really interesting. I mean, here you're looking at the mortality due to disease, and here you're looking at what the big killers in any particular country are. And I know this is actually hard to see, but the blue ones are all tuberculosis, red is HIV/AIDS, the light purple are diarrheal diseases, the light blue is malaria, and those are the big four. Then you also have dengue fever, meningitis, and I'm actually not sure what that says. But anyway, but the big four are right here, okay? So the question becomes, how do we know this? How do we do this? And this is disease mapping. And there are two major components. There's the incidence, and this is the probability, this is the technical definition, the probability of occurrence within a specified period of time. Basically, what that's saying is how many new cases are there per year. And then there's the prevalence. This is the probability of an individual having a disease. And so in layman's terms, that's the number of existing cases of a disease wherever you're talking about. So the number of the prevalence of HIV in the United States would be the number of new cases of HIV every year. Okay, so what are the methods? Well, first of all, you need to look at morbidity and mortality. Morbidity is the having the disease, the mortality is the dying from the disease. And you need to be able to compare it at different geographic scales. Okay, and one of the really big important things that you need to know is the location of the disease, and you need to understand how it spreads, right? So you have to understand the disease how it spreads to be most successful at understanding the geography, right, of the disease. You can map diseases, and sometimes those maps will help you understand the disease, but if you're truly going to analyze, okay, what's the risk here, what's going on here, then you really do need to understand the disease itself. Okay, transmission is very helpful, stuff like that. So the other thing that you need to keep in mind is that small samples can give really skewed data. All right, so if you have an incidence that's really small, sometimes it's very hard to get an accurate map, and this is going to be true especially for emerging diseases. So here's your first question. What is an emerging disease? A global outbreak of disease, a disease that is always present in a population, a disease with clinically distinct symptoms whose incidence has increased, particularly over the last 2 decades, or a disease that occurs only occasionally at unpredictable intervals. Well, a global outbreak is a pandemic, okay, and we're going to define these words later. A disease that's always present in some number is endemic, E-N-D-E-M-I-C, endemic. An emerging disease is one whose incidence has increased. It's something we need to pay attention to, and I think you can probably right now think of a bunch of those. And this is one of the reasons that medical geography has really come to the forefront, this idea of disease mapping, because of these new emerging diseases like HIV/AIDS, SARS, avian flu, H1N1, Ebola, right? Things like that. So some things have been really helpful, and a couple of those things, the improvements in our ability to gather data, electronic databases, and being able to survey populations and having more access to populations has been really helpful in order to gather and store data. Then in terms of analyzing data, GIS, spatial statistics, and multi-level modeling, all things we talked about before, but these three things have made every kind of geography better. Okay, so which of the following must be present in order for a disease to be infectious? A portal of exit from the body, an infectious agent, a portal of entry into the body, or all of these? Well, if the disease can't exit the body to the next body, well, there's no transmission. If it's not infectious, like say a genetic disease, then there's no transmission. And if it can't get into a new host, there's no transmission. So you have to have all of those. Yeah, which brings us to the idea of cases and exposure. The primary case is the person who brings the disease into a population. They're patient zero. Right? Secondary cases are those that are going to be infected by the primary case. And then the generation of infections, these are the waves of infections, right? And so you'll have an increase and then maybe a decrease and another increase and maybe a decrease. So you may have several secondary cases, right, that lead to a whole wave of outbreak, and you may have several waves within a period of time that's considered to be an outbreak. And then the index case is the first patient discovered during the outbreak. Probably not the primary case, maybe not. But that's the one that makes you aware that this is going to be a problem. And then the other thing that's really important is the reproductive rate of the disease. What is the potential of the disease to spread in a population? Okay, is it highly infectious? Is it highly contagious? Okay, so the reservoir for infection and source of infection are not necessarily the same, okay? And these are two other things that you really need to understand of the disease so you can start making predictions about where new outbreaks will occur. And the reservoir is basically where the infectious agent, right, is going to be living in the environment. Yeah, this is where it survives, it's where it multiplies, it's where perhaps where it even reproduces. That can be within a person, that can be in an animal. A lot of times it's in an arthropod, usually a crustacean, maybe an insect. Those are both arthropods. Think about mosquitoes for malaria. Soil, you've got things that live in soil or some other substance. You've got water, right, is a big carrier. Fomites are another thing. Fomites are objects that can hold the disease, things like that. And then the source is where it's actually coming from. A human, an animal, or in the environment. And I'm going to give you some examples of these later on. And then transmission routes can either be direct transmission or it can be indirect transmission. And I think you've probably talked about these a lot in terms of like your health classes, and you've probably seen them on the news. But there are those fomites, by the way, the objects. I just think that's a fun word. Okay, so when we talk about disease occurrence, some diseases are sporadic. That means you get occasional cases. They're pretty irregular, not very common. Endemic, we already defined. This is something that's just in the population at some expected frequency. Basically, it's there, you know, very predictably and continuously. Okay. An epidemic or an outbreak is where you have some illness that has a much higher frequency than normal. Okay, and so that's what we see when we have like a flu epidemic or the Ebola epidemic, right? And then a pandemic is actually an epidemic that crosses borders, right? And so this is going to involve several countries or continents, whatever, affecting large population. So the really important thing about disease mapping is that you can look at the spread of a disease, and of course all of these things that you're looking at are going to help you make predictions about the future, help you prevent the spread of disease later on. Okay. Now, there are just general diffusion, spatial diffusion. There are three patterns that you get. You have expansion diffusion. This is where you have whatever you're talking about spreading from one place to another. Whatever you're talking about stays in the original location. It may in fact intensify, but new areas are also occupied. Okay. In relocation diffusion is similar to expansion, but whatever's being diffused leaves the area and moves to a new area. There's not a whole lot else to say about that. A lot of times you have a combination of expansion and relocation diffusion, and I'm going to show you some pictures, but this can be talking about anything. You could be talking about religion, language, culture, trends, right, diseases, whatever. Okay. Expansion, we've started here, we're spreading out, we're spreading out, we're spreading out. Relocation, we started here, then it moved here, then it moved here, but it left each of these areas when it moved. And then combined is it leaves part of the area but spreads out to a new area, leaves part of the area but spreads out to a new area, and you can see how that works, okay? So most diseases actually follow what diffusion pattern? Expansion, relocation, combined, or no pattern? Well, if you think about it, it's really expansion for the most part when you start out. You could argue that eventually that pattern turns into a combined pattern because you'll have a situation where you start trying to combat the disease, right? And so you've got this prevention, treatment, whatever you're doing. But typically, when you start looking at the disease, it's going to have an expansion diffusion pattern, right? Later, as people start treating it, it's going to have a combined pattern, right? But we're going to go with expansion. Well, actually, that's not true. We're going to go with combined. So if you think about the whole event, it's going to be combined, right? If you think about before treatment, it's going to be expansion. So whole pattern combined. All right, so let's talk about one of the most famous epidemics, and actually it was a pandemic in history, and that would be the Black Death, or the bubonic plague. Okay, the cause is Yersinia pestis, which is a bacteria carried by fleas. Fleas are the vector. The actual source is the Yersinia pestis, and then it is transported on rats, typically, is how this particular version, and that's because the fleas hang out on rats hang out on ships or in caravans, and so it went from Asia to Europe in this transport route, and the transmission is person to person, or flea to person, but people get bit by the flea, but then it really takes off, and you've got high rates of person to person. On the PowerPoint that you have for each of these diseases I'm going to talk about, there is a whole nice little write-up that'll tell you all about everything you want to know about that. Okay. Now, when we look at the spread of disease, you can see that it's coming in from Asia around 1346 through 1347, and then it starts to spread out, and by 1351, so it goes into Europe, right? And then it moves pretty much along the coast, and then it moves inland. And you are looking at North Africa being affected, and then of course back into North Asia, like, you know, Russia, and areas like that, okay? And then here you have this really interesting area that's unaffected, partly because of things like a mountain and lack of trade. Okay, which of the following was the deadliest influenza outbreak in history? The 2011 H5N1, which was the avian flu, the 2009 H1N1 swine flu, the 1968 Hong Kong flu, the 1957-58 Far East pandemic flu, or the 1918 Spanish flu? Well, if you said 1918 Spanish flu, you would be correct, right? The cause is the influenza virus. This first appeared in Europe, okay? Its transmission was person to person, and you can see that it spread all over the world. By the time this was done, it ended up killing an estimated 20 million people. Okay, and that's just the flu, and the flu actually is a huge killer. It kills lots of people every year, but this was the big one, and look, it spread so fast, right? In less than a month, okay, you've got almost the entire country has cases of the Spanish flu. And here is the H1N1, or the swine flu, from 2009, and you might actually remember this. This version of the flu was a real problem because it attacked young people as opposed to the normal cases every year that are mostly affecting the elder, in terms of serious complications, the elderly, children, and the infirm. This was attacking healthy adult individuals, and there were a lot of cases. It was a big problem. And then of course there was the H5N1, that was the avian flu that happened in 2011. But anyway, so lots of flu every year, and occasionally you get either an epidemic or a pandemic. All right, what about malaria? Malaria is a huge killer. Actually, it's the third biggest killer around the world, behind AIDS and respiratory and diarrheal diseases. it's sometimes called marsh fever or ague. It is caused by the Plasmodium protozoa that is carried in the gut of the Anopheles mosquitoes. There are actually several species of Anopheles. Not all of them carry the Plasmodium, but you don't know which one's biting you, so there you go. Written records show that we have confirmed cases of malaria for at least 4,000 years. However, it's probably been endemic to the population. We already talked about what endemic was. It's been endemic to the population for the last probably 8,000 years or so. And we know that it's been around for about 50,000 years. Okay, the transmission is from mosquito to person, so you really do need to get bitten by the mosquito in order to get it. And here I just put this slide in here for you about the life cycle, because I think it's interesting and I think you might want to know because it is such an important thing going on in the world. Okay, in 2002, these are the estimated numbers of malaria cases, and you can see that it is affecting equatorial regions a whole lot. We don't really have a problem with malaria. Most developed nations do not, but you can see all of these places. And then when you start looking at the actual risk for malaria, okay, it is a really distinctive pattern. So when we start thinking about that pattern, which of the three factors, right, elevation, rainfall, or temperature, seem to be the most closely related to malaria? Well, looking at this, equatorial regions, all hot, right? Well, temperature could be a thing, but look, the Sahara and the Middle East, I mean, super hot, but they don't seem to have a problem. What kind of habitat do you find in all of these places? That would be rainforest, right? So it is going to be rainfall that is the problem. Mosquitoes breed in warm standing water. So while temperature is important, it is the rainfall that is the most important. Okay. Now, moving on to AIDS, which is the next biggest killer. Okay, the cause, of course, is the human immunodeficiency virus. There are two versions, the HIV-1, that is the global version, and then there's HIV-2, which currently is restricted to Africa only. And this is what the virus actually looks like. It hides in your immune system. It actually hijacks your immune system to make copies of itself. If you have any questions about that, please ask me in class. I'm happy to talk about it with you. Its source is African monkeys. Other primates get a version called the simian immunodeficiency virus, and most of those are actually not able to jump species, but HIV is, right? Well, the version of that jumped to species that's now called HIV was one that is a species jumper. Let me just clarify that really quickly. Okay, transmission is from person to person, typically through risky behaviors, unprotected sex, intravenous needle drug use, right? Well, the needle part, that was kind of redundant, but intravenous drug use, okay? So unsafe choices. And this, I think, is a very interesting story. You can go to this website and you can see this woman has actually agreed to be filmed for 90 days, so she can talk about her situation. And, I mean, you can see that this is a very serious thing. And she's not alone. There are lots and millions of people that have AIDS, okay? And so this is a map that looks at the prevalence of HIV, AIDS in the population. And when you start looking at, the causes and how many people, so here you're talking about use of contaminated needles in Eastern Europe and Central Asia. That's the main cause, right? In Russia, it's also, you've got a serious problem with drugs and stuff like that. The rest of it is caused by unprotected sex. Okay, and then when we look at sub-Saharan Africa, they account for 2/3. Those cases account for 2/3 of all of the cases in the world, right? And so the people that are suffering from AIDS most are going to be in sub-Saharan Africa, and you can see that the percentages are, crazy high, right? So in South Africa, the southern portion of Africa, you're talking about up to 1/3 of the population actually has HIV. And if you look at this is the projected population structure of Botswana in 2020, which is right around the corner, with and without the AIDS epidemic. Okay, without AIDS, you have this very standard developing rapid population growth pyramid. With AIDS, you can see that there's this swath that's cut through the healthy working individuals. They are not healthy. They are contracting AIDS and dying at alarming rates. This is really catastrophic for societies. You don't have a labor force. You have a lot of younger people. You have a lot of orphan children. And you have a lot of children who are born with AIDS. And then you also have a decrease in the number of children that are born in general, right? So not good stuff. And then when we look at the spread in the United States, the index case for the United States is in 1981. 1984, you can see that it's spreading to major cities, right? And then, of course, by 1990, you can see it spreads really coastal, right, coastal. Then it starts moving into the higher populated areas. Again, you're seeing cities, right, cities. And then, of course, by 2010, it's pretty much everywhere. Right, and there's not a state that doesn't have HIV/AIDS cases. Okay, and then of course the latest is the Ebola epidemic. Now this is caused by a particular genus of viruses, the Ebola virus genus, which is part of the family Filoviridae, and these are pretty. This is pretty vicious, this whole family. This is going to include Marburg and Hanta and Lassa are also hemorrhagic fevers. But Ebola and Marburg, which you may have heard of, are these Ebola viruses. Okay, the source of Ebola is unknown, and this is actually the virus, the Ebola virus, and then this is a gentleman who's in the earlier stages of the virus. Again, the source is unknown, but we do know the transmission. It's person to person through body fluids. HIV/AIDS is also through body fluids, by the way, but in this case, it's really caregivers and body disposal. You can live with HIV and not even know you have it. You can have AIDS for a very long time before you become non-functioning. But so there's a high risk that you're going to expose someone else to HIV. Ebola is a very fast killer, and so mostly the people who are going to be at risk are going to be caregivers, right, healthcare workers especially, or people who are involved with body disposal. If you're handling someone who has died of Ebola, you're going to be most at risk. And again, it's because this is transferred through body fluids. And unlike HIV/AIDS, Ebola is a hemorrhagic fever, which means that there is a lot of fluid at the end. Basically, people bleed out. Okay. Here, I just put this in here so you to understand the progression of the disease. Basically, it kills you, kills like somewhere between 50 and 90% of people, and within about 2 weeks of getting it. But after the first week, that's when you're going to expose other people, because you're not really feeling any of the symptoms. But once you start feeling the symptoms, it's a very short period of time until things go really wrong for you. Anyway, when we look at the West African Ebola virus outbreak, okay, you can see that you have all of these countries, and they're not actually connected. So what's happening here? People are flying from place to place, and so you can see not this kind of continuous expansion like we've seen with the other diseases. We see this kind of like hop and skip situation, right? And that is because of airline travel. I mean, people don't have to travel through areas to get someplace anymore. Okay, and then this actually is just a map of the initial region for the outbreak. And then, of course, you can see some other areas here on this map. And it gives you some number of cases. This was the end of October of 2014. Okay, and then this, I just actually really kind of like this because you can see people who are infected versus the number of people that have actually died, and a lot of that has to do with health care that they have available to them. And the other thing that it shows is actually a whole history of Ebola outbreaks. This is certainly not the first. Okay. That is it for our conversation about mapping and just a couple of examples of how we've mapped diseases. and why we did that and what it shows. If you have any questions at the beginning of class next time, please let me know, and thanks for listening.